Chengcheng Tang, King Abdullah University of Science and Technology, Saudi Arabia.
Good designs should be functional, artistic, and constructible. For functionality and artisticity, Gaudi created hanging models with tension only, then viewed them upside down for wonderful masonry structures that can stand with compression only, that could be built by stones. But it didn't tell us how to build them. So Sagrada Familia is still under construction after a whole century. In recent projects like the Eiffel Tower pavilions, my colleagues have used geometry to help the fabrication process. But usually, it takes a long process to iterate over physics, art, and geometry to find the feasible solutions, which are usually compromised. So we would like to propose computational approach, unifying physics, art, and geometry for functional, artistic, and constructible designs. Mathematically, it guides designers to navigate a space of feasible designs with the guidance of aesthetic considerations. For the maximum creativity, let's try on a static equilibrium structure with both tension and compression, so it could be built by glass and steel. Every face here is planar, so the ordinary planar glass panels could be used, which are the most cost-effective ones. The computation quickly suggests feasible designs after user edits. Note the compressive forces on both sides to support the structure and tension to hold the top back. If we just slightly change the assumption and only allow compressive force for masonry designs that could be built by stones, and stone would be much stronger if pushed than pulled. The computation now looks pretty much similar as before, but please note very carefully here, when the user is pulling the upper part outward, the computation does not follow, because it has to respect the physics and prevent this structure from falling. So this is not the falling wall I'm going to break. So by the way, those structures which have overlaps along the vertical direction but can still stand with compressive forces only have never been demonstrated before, and many researchers thought they do not exist. But here, we can indeed discover them and even to design them. And as the mathematics behind is universal, a lot of the other design problems could be solved in very similar manner, such as those purely artistic, curved origami designs. And by breaking the wall of computational design, more people could become designers to realize their ideas. And with the gaps between disciplines being harmonized by different, please.